This illustration is analyzing a block sliding under a block. Here the figure shows a system of blocks with masses 40 and 20 kg, and the block B is kept at rest by a string OP, as we can see. The friction coefficient between A and ground is 0.2 and that between A and B is 0.3. We are required to find the minimum mass of block C required to slide the block A. Now in this situation, if we draw the free body diagrams, we can calculate the friction acting on A. One, it will be overcome by the weight of block C, it will start sliding. So in solution, we start with the free body diagram. So if we draw free body diagram of block A, here you can see. And to analyze the free body diagram, let's have a look on this figure where we can analyze all the forces acting in the system. Say a normal reaction N1 is developed between block and ground, and a normal reaction N2 is developed here, and a tension T2 is acting in this string and a tension T1 is acting here. So the value of T1 will be provided by the weight of block C, so this can be written as mcg. So we can calculate the value of T1 and get the value of mass of block C required to slide it. As A has a sliding tendency toward right, friction on it will act in leftward direction. Here this will be F1, this is F2, and one F2 will act on block B in opposite direction, and reaction of F1 will act on ground, which is not going to be used in this case. So in free body diagram, we can see on block A, downward is its weight, that is 40 G, plus the normal reaction due to block B, which is N2. In upward direction, N1 is acting on it. Toward right is the tension T1, and toward left is the two frictions acting on it, F1 plus F2. Similarly, if we draw the free body diagram of block B, here we can see block B is experiencing the weight 20 G in downward direction. The normal reaction due to contact with block A and 2 is in upward direction. Toward right is the friction F2 acting on it, and a tension T2 will act on it at an angle 30 degree with the horizontal. Now here we can write for sliding of the block, both of these friction must be at limiting values. So in this situation we can write to slide A, friction F1 should be equals to, here friction coefficient is 0.2, so this 0.2 N1, and friction F2 should be equals to 0.3 N2. So let's first calculate N1 and N2, then we get the values of these frictions, for which we can write the equations here. As in this particular case, in vertical direction and horizontal direction for block B, we can write the equation as T2 cos 30 degree, which is T2 root 3 by 2 is equals to the friction F2, which can be written as mu N2, and the value of mu over here is 0.3, and N2 is the normal reaction, and the normal reaction N2 can also be calculated here as in vertical direction. We can balance the forces as N2 is equals to 20 G plus this T2 sine 30 degree, that is T2 by 2. So if we substitute the value of N2 from this equation to here, this will give us T2 times root 3 by 2 is equals to 0.3 times 20G can be taken as 200 plus this T2 by 2. And further on simplifying, we can take this T2 on left hand side and solve the value of T2. So here we can see 0.3 multiplied by 200 is 60. 60 multiplied by 2 is 120. So this 120 divided by root 3 minus 0.3, which is 120 by 1.432 Newton. This is the value of tension in a string T2 we are getting. If we have got the value of T2 from here, we can easily calculate the value of N2. Here we can continue. The value of N2 is equals to 20G, which is 200 plus T2 by 2 is 60 by 1.432, On simplifying, you'll get is 241.9 Newton. So this is the value of N2. If we substitute here, this will give us the value of friction at the surface between A and B. This 0.3 multiplied by this 241.9. On simplifying, you'll be getting this value as 72.57 Newton. If we have got the value of N2, we can apply the same for equilibrium of block A in vertical direction. That will give us the value of N1. So here we can see the value of N1 we are getting is 40G plus N2. So this will be 400 plus N2 is 241.9 and this equals to 641.9 Newton. If we substitute the value of N1 over here, we'll get the value of this friction, this 0.2 multiplied by 641.9, which on simplifying will give us 128.4 Newton. As we have got F1 and F2 here, we can directly write to slide block A. Again, we can continue here. We can write the value of T1 should be equals to F1 plus F2, which is equals to, if we add these two frictions, this will give us 200.97 Newton. If this is the value of T1, the mass of block C required to slide it is T1 by G. If we take G as 10, this will be 20.097 kilogram. That will be the answer for this problem.